Okay, we're going to continue on with graphing and looking at graphs and ordered pairs and equations. This is going to be a lesson that's a little tough today, so it might take a couple days for this really to sink in. So give yourself a break if it's a little hard at first, because this is a hard idea. We're going to be talking about direct variation. And direct variation is when we have two things that directly affect each other. Okay, so let me give you some examples and see if this helps. So an example of direct variation would be if I want to go to the movies. Okay, going to the movies is the direct variation would be the cost. How much is it going to cost me to go to the movies is directly related to how many people I'm going with. So if I go by myself, I'm going to pay for one ticket and it'll be one price. But if I go with my husband, then I'm going to pay for two tickets and it'll be a different price. And then if I take my whole family, if all 5 of us go, I'm going to have to buy 5 tickets and the price is going to be even higher. So the cost, the price to go to the movies is directly related. It directly varies. It changes directly based on how many people I'm bringing. And so we're going to look at these direct variations on a graph and in a formula. So when we're looking at a graph, there's 2 things that have to happen for a graph to show a direct variation. The first thing is that the graph starts at 0, 0. So think about it. This would mean I buy 0 movie tickets and it costs me $0. So obviously if I don't go to the movies and I don't buy any tickets, then I don't spend any money. So yay, 0, 0. Okay? So that's the first thing. The next thing that has to happen is that the line is straight. And the straight line means that it's going up at a constant rate, which is what we just learned was slope. So for every movie ticket I add, the price goes up by a constant, the same amount per ticket. Okay, so I'm looking for 2 things. I'm looking for the point 0, 0 on the graph, and I'm looking for a straight line. That's how I can tell by looking at the graph if it's a direct variation. Now, the second part is where it gets hard. That's the equation. The equation is y equals kx, and y is your dependent variable. That means if I'm talking about the movies, the cost, the price directly depends on x. X is your independent variable. Right? I can decide how many people in my family get to go to the movies. I can go by myself. I can bring one of my kids, although the other 2 might not be very happy with me, but I could choose to do that. Okay, so I get to choose how many people go to the movies. So X is independent. We choose that. And then that is going to change our dependent variable of Y. Then we've got this number k. K is the slope. Slope is also the unit rate. How much does one ticket cost? How much are we moving up per amount? Okay, so we're going to look at some graphs and we're going to say, are they independent, or are they direct variations, or are they not direct variations? Okay, so we're looking at this chart, and this is Adam's growth chart. Okay, so when Adam was 3 months old, he was 22 inches. And then when he was 6 months old, he was 24 inches. And then when he was 9 months old, he was 25 inches. So we want to know, is his height directly variant does it change directly by his age? Okay, so let's draw a graph. So we graphed the points. Now, I'm looking for two things. Number one, does my graph go through 0, 0? No, because guess what? Even when Adam was 0, he wasn't 0 inches tall. He actually came out a certain length. Okay, so no. And then number two, is it a straight line? Well, no, look at this line. It's like jaggedy. So is this a direct variation? No, because your height is not directly related to your age. Now, it kind of is, but if it was a direct variation, every single 2-year-old would be the exact same height. Every single 10-year-old would be the same height. Every single 30-year-old would be the same height. So that would mean, since I'm the oldest person in the room, I should be the tallest. Now, those of you who've seen me standing up, you know that I am not very tall. In fact, there's always quite a few of you who tower over me. And you're way younger than me. So height and age do not vary directly. So looking at a graph is one way to tell whether something has a direct variation. Now, there's another way to see if something has a direct variation. So we just looked at making a graph. The second way is to look at proportions. See how we keep coming back to proportions? That's because they're so awesome. So I'm going to look at these ratios. 8 ounces in 1 cup, 16 ounces in 2 cups. If I want to know if this is a direct variation, I can check their cross products using a proportion. So 1 times 16 is 16. 8 times 2 is 16. And look at that. This is a proportional relationship. So yes, it is a direct variation. Okay, so 2 ways to tell if something is a direct variation. Number 1, draw a graph. If the graph goes through 0, 0 and is a straight line, here's an example of what we just looked at, then yes, we have a direct variation. Method 2 is look at the ratios and check their cross products. So those are the 2 ways to tell if something is a direct variation.